Here are the solutions to the guided practice. Hopefully you will find that you have success with this. And again, if there is something that you're not sure about, please review the video. That's what it's here for. You know, if you're in class, you can't exactly ask me to rewind and say everything verbatim over again, but that's the good thing about having the video is you can go back and review it as many times as you need to. That's the hope here, is that you take advantage of those opportunities to do those things. So, number one, find f of 4 if f of x equals x minus 6. And I'm going to be very straightforward with you about the requirements for this. You do need to be very specific about how you display your solution. So what would happen is you would substitute the 4 in everywhere that there is an x. I would like to see this written on your paper, especially if obviously if it's a short answer. So that's the first part, is you are substituting the 4. And then you don't just write -2. This is a function. It's a function and a solution. So it's not just -2, because obviously 4 minus 6 is -2. But you write it this way. F of 4 equals -2. That way you have the fact that basically you have an ordered pair here now. So if we were going to graph this, the ordered pair would be 4 comma -2. I think I mentioned that in the very first part of the lesson, is technically speaking you have an ordered pair here. It's a relation, set of ordered pairs. So this is one ordered pair, 4 comma -2. That's why it's important to group them together like that. So this is what your solution should look like. Number 2, choose 4 values for x to make a function table. They drew it for you, congratulations. Then state the domain and the range. So again, if you're heeding my advice, which, you know, hopefully at this point, I don't know what you're doing if you're not taking my advice. It's kind of, you know, I don't know. Take my advice, believe me. It's worth it, in my opinion, obviously. I'm kind of biased, but you get the idea. So here's what my table should look like. I recommend -1, 0, 1, and 2. I'm going to rewrite the rule substituting in each of the values. Now this is going to look a little bit strange, and you have to keep in mind the integer rules. This right here hurts my brain to look at, 8 minus -1, so just understand that that's going to become 8 plus 1. Alright, I can't, my OCD can't handle subtracting negative numbers. It doesn't work for me. So this next one is going to be 8 minus 0, obviously. The next one is going to be 8 minus 1. And lastly, I'm going to have 8 minus 2. So I'm going to go ahead and calculate each of these. 8 minus -1 becomes 8 plus 1. That's going to be 9. 8 minus 0 is 8. 8 minus 1 is 7. And 8 minus 2 is 6. So there is my solution set. Oh, there go the big numbers again. AKA what is going to end up being my range. So let me just fix this real quick for you. I don't know why this isn't cooperating right now. Something to do with my mouse, I think. That looks a little better. Throw that in there. Good enough. So the last part, state the domain and the range. The domain is the x values or the input. The range is the output. So it should look like domain. Use your braces. I know I cheated. I have a button on the computer. -1, 0, 1, 2. Please put those in order from least to greatest. And then the range is 9876. Actually, I mean, you should put these in numerical order also. So 6, 7, 8, 9, least to greatest. And you're good there. That's what that looks like. So again, perfectly fine to abbreviate D for domain, R for range. That's what that looks like. Number 3, a hot air balloon can hold 90,000 cubic feet of air. It is being inflated at a rate of 6,000 cubic feet per minute. The total cubic feet of air, A of t, is a function of the time in minutes t. Identify the independent and dependent variables. Okay, so again, real simply put here, the independent variable is the standalone, t. The dependent variable is the A of t, because A of t depends on what t is. So again, I'm going to write this as a sentence. The independent variable is t. In other words, time. Time is the independent variable, would be another way to say that. And you can write this as a compound sentence with a comma in the word and, or some of us like to use semicolons as much as we can because they're underutilized in the English language, in my opinion. The dependent is A of t, or cubic feet of air. Good to go. What values of the domain and range make sense for this situation? Okay. Theoretically speaking, we're looking at the same type of problem as we did with the peanuts, peanut butter, jars of peanut butter and cans of tuna. So, a couple of things. First of all, we're not talking about peanut butter and we're not talking about tuna. So, our situation can be a little bit different. Think about it in terms of filling up a balloon. Okay, you're filling up a balloon, certain amount of cubic feet per minute. Okay, it's a measure of volume. In this case, air still taking up space, all right, even though it's air. But at any point in time, it's not going to be a whole number. It literally could be any positive value. It could be a decimal or a fraction. It could be, 8 2/3 cubic feet. It could be 100.7. It could be anything, literally any positive value. So for the domain, the input is going to be any positive value. The domain is the set of positive numbers. Any numbers. I mean, you could put rational in there. Technically, you could put irrational in there also. So the domain is a set of positive numbers. Now, that being said, so it literally could be anything as long as it's positive. The range, what we did not have before is a limit set. It says a hot air balloon can hold 90,000 cubic feet of air. That means after that, I know it's a hot air balloon. Hot air balloons do pop. It's not common, but it could happen. In other words, there's a capacity, a maximum capacity of air that the balloon can hold. So yes, 6,000 cubic feet per minute, it is going to go in increments of 6,000, but it cannot exceed 90,000, if that makes sense. 90,000 is the maximum. So range, it cannot be bigger than 9,000, basically, is the idea here. All right, so I'm going to write this down here. The range basically has to be, if you think of it in terms of what output values could you possibly get, is basically going to be between 0 and 90,000. Okay, so the range is between 0 and 90,000, because 0 is the minimum. When it's empty, it has 0 cubic feet of air in it, right? And then 90,000 is the max. It can't be filled past that. So that's what the range is going to look like. Now, it's still going to increase in increments of 6,000 cubic feet per minute, but we're good here with just a range of between 0 and 90,000. So lastly then, write a function that represents the total amount of air. Okay, so that was our equation, y equals 6,000x in this case, but I'm going to turn that into a function. So write a function to represent the total amount of air. So if I'm considering, this is my thought process, y equals 6,000x, then all I should have to do again is rewrite my situation using the input and output values that they gave me. Alright, so I've got A of t, which is going to represent the y, and t, which is going to represent the x. So I'm simply going to rewrite this using those values. So A of t equals 6,000 t is my equation. And then after that, I'm going to sub in 6 for t. So I'm going to have a of 6 equals 6,000 times 6. Calculate that. A of 6 equals 36,000. And then this is going to be cubic feet. or you could have feet with the exponent of 3 up there, but it's 36,000. I should probably put my comma in there. 6 times 6 is 36 with 3 zeros after it. 36,000 cubic feet. All right. So there's your guided practice. Again, review that as much as you need to. Your homework assignment is on the next page. Please make sure that you have that ready to go for tomorrow. Thank you very much. Hopefully this worked well for you, and we can continue with this at various points throughout the school year.